we have covered a lot of great ground as we've discovered and worked with static routes with IPv4. So in this final review, I'd like to present a challenge, an opportunity to help verify and reinforce our skills in the world of static routing. And here's what I propose we use for our topology. Let's use two routers. We'll call this guy R1, and any recommendations here would be great. R2, that works. And let's have a PC over here, and let's have a server over here. And for the networks, let's have an Ethernet network coming off of gig 1/0, which goes to 0/0 here. And that can be the 10.12.0 network with a 24-bit mask. And let's also use a serial interface to connect the two together as well. So I'll use a slightly different color for that. How about yellow? Bam, bam, bam. So this would be serial 3/1 and serial 3/3/2. My mouth was going, but my pen wasn't. And then for over here, we have gig 0/0. And this network over here can be the 10.1 network. And with a 24-bit mask, the PC's at .10. Fantastic. And then over here off the right, off gig 1/0, we have the 10.2 network with a 24-bit mask. And our server is at 10.2.0. And we'll put him at 200. So here's my idea about how we can reinforce the concepts that we've learned. And that is to do the following. On R1, we're going to create a default route using 10.12.0.2 as the next hop. So on R1, that would be R2's gig 00 interface, which has the IP address of 10.12.0.2. Also, create a floating default route using 10.21.0.2. So the serial connection has the network of 10.21.0, and R1 is .1 and R2 is .2. So that'll be a good rehearsal of playing with the administrative distance as we create that second default route with this next hop and an administrative distance higher than the default of 1. And then also on R1, let's create a loopback interface 0 with an IP address of 1111, 32 bits in length. And then over on R2, we'll create a static network route so that R2 knows how to reach the 10.1.0 network. That's over here on the far left using the next hop of 10.12.0.1, which is R1's gig 1/0 interface that has that address. And then secondly, on R2, let's create a static host route that goes to 1111/32. That's the loopback that we just created on R1 using the next hop of 10.21.0.1, meaning going over the serial link, going to that specific IP address of 1111. So here's what I'd like to propose. I would propose parking here on this slide for a while and then attempting the lab itself, just to implement each of those aspects, those 5 things. Now, each of those items, we've covered the concepts and the basic configuration of how to do those techniques in our previous videos. So if you want to, if you're looking at this on a tablet or something else where you don't have access to the hands-on lab right now, no worries. Stick around for a few seconds and I'll walk you through the solution. But I think the cool thing would be is that at some point, if you sit down at this lab and practice it on your own, and every time you practice it, it's going to help you become better and better at both configuring and verifying Cisco gear. So I'm going to go ahead and pause for a few moments, and then I'll be right back. And together, we'll walk through the solution. All right, so here in the lab, we're going to go ahead and log on to DCNUG as the administrator. And then we'll launch PuTTY up here in the upper left. And we'll go to servers, and we need access to R1, and we need access to R2. Great. So our first task on R1 is a default route using 10.12.0.2. So we'll go into configuration mode, and we'll do IP route with the characters for a default route, which is 0.0.0.0 space, 0.0.0.0 space, with the next hop of 10.12.0.2, and press enter. So now with the default route in place, we need a floating default route using 10.21.0.2. So I'm going to hit the up arrow key, because all we're going to do here is we're going to change the next hop of 10.21.0.2, which will go over the serial interface, and we're going to add a space and then add an administrative distance. Anything higher than the default of 1 will make this a floating static default route. So we'll go ahead and put 5 and press enter, and we are good to go. We can do a do show IP route just to verify. So now we have a default route, and we also have in the background the floating default route standing by. Next, let's create a loopback interface. So we'll go to interface for a loopback, and the instruction said 0. So we'll create interface loopback 0 and give it the IP address of 1.1.1.1 with a 32-bit mask. And this is how we spell 32 bits in dotted decimal, just like this. Boom, that is done. And that's our configuration tasks for R1. Next, let's go to R2. So we'll swap over to R2, clear off the screen a little bit, and let's get into configuration mode. The first task says create a static network route to 10.1.0.0/24 using an XTOP of 10.12.0.1, which is R1's gigabit Ethernet address. So to do that, we'll do IP route. We'll put in the network 10.1.0.0. We'll put in the mask for that network, which is 24 bits, and then the next hop of 10.12.0.1, and press enter. Secondly, it's asking us to add a static host route to that loopback on R1, the 1111 address. So to do that, we'll do IP route. We'll put in the IP address. And to specify that we're interested in mapping to those 32 bits, we're going to put in a 32-bit mask of 255.255.255.255. And then we're going to specify the next hop of 10.21, which is over the serial link, .0.1, just like that. Then we'll confirm our work. We'll do a show IP route. And if we do that again and throw in static, it'll thin the herd for us a little bit. And there's our two static routes. One for the loopback interface of 1111 and one for the network 10.1.0. And then for our test, let's go ahead and verify that we have full reachability. So if we go to the client PC, and here on the client PC, we'll go ahead and log in. Let's bring up a command prompt. Any way that you want to would be great. And here at the command prompt, let's do a couple things. This is important. We'll do an IP config just to verify that we have the IP address that we think we do, and we have the correct default gateway. So that's R1. That's super. And then we can do a ping out to something on the 10.2 network. And the server out there is at 10.2.0.200. And bada bing, bada boom. And you know, if we want to verify the path that we're taking to a destination, we can use the traceroute command. So on a Windows computer, it's TRACERT space, and I like to throw in the -D, which means don't bother trying to do name resolution for us. And then we can put in the IP address of 10.2.0. And it is 200. And that'll show us the hops in the path. So the first hop was 10.1.0.1. That's R1. Fantastic. The next hop was 10.12.0.2. Fantastic. And you know what we also could do is we could go back over to R2 for a moment. Let's do that. So here on DC, now back on R2, because in our routing table it says to get to the 10.1 network, go ahead and use 10.12.0.1. But if you're going to 1111, take the path through the serial link. We could actually verify that's happening by using traceroute. So let's do that. Let's do a traceroute to 10.1.0. Now the PC over on that network is at .10. And we already know that it has functionality. So let's use that address again as a target. And you'll notice the first hop there is 10.12.0.1. That's R2 using its Ethernet interface with the next hop of R1's Ethernet interface. Fantastic. So if we did a trace route to 1111, what would we expect to have happen? I'm putting in commas. .1.1.1. What we'd expect to happen based on this route, we would expect that traffic to be forwarded over the serial interface with the next hop of 10.21.0.1, which is R1's serial 3/1 IP address on that interface. So let's test it. We'll press enter. And sure enough, that hop was 10.21.0.1. And one of the interesting things about routing in general is that we could sit here, IP route, at least I could sit here, and I could just enjoy interpreting this routing table all day long. And they've gotten easier over the years. When I first started, they didn't have the routing table sorted in like any kind of numerical order. You had to kind of hunt and peck and search. And so it's gotten better over the years. But there's a lot of information here about what's going on and what the router is thinking about. And what we'll do as we go into other skills, including skills on dynamic routing and predicting which interface the router will use, we'll be visiting this again and again. And the more time that you and I have in practicing and being exposed to the routing table, the better we're going to get at it. And the better you are at it, the more able we are to troubleshoot and manage and correct networks that are having a problem. And I have thoroughly enjoyed this time with you as we've taken a look at the skill of static routes in the world of Cisco systems. And I look forward to seeing you in the very, very next skill. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.